All right, so yesterday we talked about what the transformations do and how they affect the actual graph, how they affect the coordinate points, right? And today we're going to continue. So our vertical shift is outside. All the vertical things are outside the parentheses. If I add or subtract, adding goes up, subtracting goes down. If I put in something on the front of my f of x and it's bigger than 1, it's a stretch. Less than 1, it's a shrink, but it's by a factor of that number. If it's negative on the front, it flips it over the x-axis. All of that affects the y's. Then came the horizontal stuff, and the horizontal stuff all happens inside. Inside is your shift left or right, and your stretch and shrink for your horizontal, and your reflection over the y-axis, which affects your x's. So if I had plus or minus a number on the front, and then there's the number, obviously. Sometimes you see a, but I'm just going to put like numbers literally here. And then inside could be plus or minus a number, and then x plus or minus a number, and then plus or minus the number at the end. So each of these individual spots, okay, obviously impact our graph. Everything outside affects the vertical, which affects what? The x or the y? The y. Does it affect the domain or the range? The range, right? Because the range is the y. Does that make sense? So everything outside is y and range, okay? Everything inside affects the x. So the plus or minus flips it over the y-axis, but that means it changes the x. The number on the front is a factor of 1 over that, or the reciprocal of it. And that means we would change our x values. And then the adding and subtracting inside the parentheses means we're going to shift our x values. All of those affect the domain. Does that make sense? Inside is x's and domain. Outside is y's and range. And everything that's inside is like either the opposite that you think or more complicated. If it's just a factor, we do 1 over it. If it's inside the parentheses, we go the opposite direction your brain thinks. Everything outside is the natural progression. The other thing we talked yesterday was the importance. We went through these. We talked about the importance of the order in which we do things. For the vertical changes, we stretch before we move. And for the horizontal changes, we move before we stretch. So if you just think about this in terms of like natural order of operations, if I had something that said -4 times x, well, let me make this an actual number. 2 plus 3 minus 1. Think about what you would typically do in order of operations. What would you typically do first? You're going to do the parentheses first. So the same here. I come to the inside the parentheses, and I would say that x minus 3 is a shift right 3. Then if there was something being multiplied inside this, so if it said something like this, then I would move to the multiplication of that. So that's the same here. We then move to the multiplication that's happening inside the parentheses. And then after that's done, I would multiply by the -4 on the front, and that's what we do next. We'd use that vertical stretch to multiply by the -4. And then the very last thing I would do is shift it up or down, or subtract the 1, which in this case is the move down. So if you remember the rules of simple PEMDAS, like order of operations, you're always working innermost out, then the order in which you stretch and shrink is the same. Is the importance of the order in which, all right, we skipped this yesterday. So given the graph, F has a domain of -2 to 4, and the parentheses and the brackets should never change. So if it starts parentheses, it's going to stay, and if it starts bracket, it's going to stay. And the range of -3 to 7, let g of x be f of x minus 2 plus 3. So start with the parentheses. If it's x minus 2, what kind of translation is that? To the right 2. Is that affecting your domain or your range? Domain. So I go to my domain, and if I want to shift those to the right 2, what are you going to do? Add 2 to each of them. So my domain changes to 0, 6. Then I go to the next translation, and this is the +3. The +3 outside the parentheses does what?
Up 3.
Up 3. Up 3, is that affecting your domain or your range? Good, it's affecting your range. And what are you going to do to go up 3? Add 3. So it becomes 0, 10. So the ending domain is 0, 6, parentheses on the 0, bracket on the 6. And the ending range is 0, 10, bracket on both. Yep.
What did you say, like if it starts parentheses again?
Like this will never change from bracket to parentheses.
Oh, like from the
So,
original.
yeah.
Okay.
Yeah.
And what are their brackets again?
It's just what the given domain and range is.
Okay. And
Yeah.
the zeros, obviously no brackets.
Because this one had brackets, so I kept them. This one had a parentheses and a bracket, so I kept it. You keep it. Yeah.
That's it.
All right, now go to example 8. Given the graph for f as the domain of -2 to 4 and the range of -1 to 5, let g of x be 3 times x minus 1 minus 2. So let's go parentheses first. X minus 1 is what? Shift to the right one. What are we changing? The domain. We're going to add 1 to each of these. So my domain now becomes -1, 5. Then I'm going to work my way out. So the next thing is multiply by 3 in the front. There should be a G here. There's a G missing. Okay, there's a G there. Okay? Or no, there's an F. Sorry, not a G, an F.
I can't see where that is.
It's in between the 3 and the parentheses. Yeah.
For the dilation, when it's in the parentheses, we use the reciprocal.
Correct. But if it's outside, what is it?
It's the same.
This is a what kind of stretch?
Oh, it's a
Vertical. So what's it going to change? Your domain or your range?
Range.
Your range. And do we keep it or we make it its reciprocal?
Keep it.
We keep it. So we take our range and we multiply by 3. Now this is our new range. Okay. And last up, the -2. What does that cause? Vertical shift down to. What am I changing? My domain and my range?
The range.
My range. And I'm going to subtract 2. So the ending domain was -1, 5 with a parentheses on both. And the ending range is -5, 13 with a bracket on both.
If it was like -3, or like if it was just negative would we multiply it by the first?
Yeah. Actually, is there not an example like that? Because there is one, like the homework, and this is like, they love this. All right, let's say it said g of x. I'm changing the example, so pay attention. Let's say it said negative. Let's add this, 2x plus 1 plus 3, okay? We're going to start with the same domain and range. Domain, -2, 4, range, -1, 5. Start with the same one, okay? But add this example. So we go innermost first because we move before we stretch on our horizontal. So the first thing I'm going to do is the x plus 1 causes what? This is left 1, which means I change domain by subtracting 1. So now my new domain becomes -3, 3. Then I go 1 step out to the 2. The 2 inside the parentheses is what? It's a horizontal, so we make it its reciprocal. So this is a horizontal dilation by a factor of 1/2. What am I changing? Domain or range? Domain. I'm multiplying by 1/2. So now my domain becomes -3/2 and +3/2. Still with me? Yeah.
For the negative, it's gonna be a reflection, but what if it's a negative and then number?
You would just multiply. So I put that. So here, let's make this -7 on the front, okay? You just multiply.
Always multiply.
So this is technically 2 separate changes. If I'm describing them, it's a reflection and a stretch.
Okay.
But when we're changing them, we can do it together.
It doesn't matter what order.
Nope.
Okay.
Okay, now we're going outside. We have to do that before we do the move. So we have to do, but this we can do together.
So you always do like the horizontal first, and then get out. You always do that.
Well, the order of horizontal and vertical doesn't matter because you're affecting the domain and range separately. But within the horizontal, the order matters, and within the vertical, the order matters. Within the horizontal, move, then stretch. within the vertical, stretch, then move. Yeah. Okay, so, but I just do the habit of doing it in the same order so you know that. All right, so now I'm going outside that I added the -7. That means it's a reflection over the x-axis and it's a stretch by a factor of what? 7. So I literally multiply by -7 and this becomes +7 and -35. And then what's the last translation? +3. What is that affecting? The range, it's going up 3. I'm going to add 3. I get 10, -32. Now, I cannot keep this like this because this is an interval notation. And what has to be true about interval notation? Smaller to larger. So these switch. It becomes -32 to 10. So it has to be smaller to larger. Okay? At the end. This is our range. That's in any interval notation. When you describe interval notation, it has to be smaller than larger.
Miss Professor, where did you get the 7 from?
I added it in because he said what would happen if there was a number there.
Into the range.
Correct. Yeah. That 7 is vertical, so we leave it alone. Over the x-axis. The Okay, so now with algebra, we didn't do either of these? No. Okay, with algebraic, this is where I would say just be careful and take and plug in instead of overthinking what you're doing with your translations. So we go back to like function notation. Everywhere there's an f of x, I'm literally just going to replace the f of x. So I'm going to take this and I'm going to plug it in. Anywhere it has something inside the x of the f of x, I'm going to take that and plug it in there. Does that make sense?
What's there?
There.
Oh, you put it on.
There.
Okay, well, how about the first one then?
So this, nothing's getting plugged into my original because it's just x, which means literally replace my f of x with what f of x equals. So 3 times x squared plus 4 minus 1. Then distribute. So the 3 gets distributed. 3x squared plus 12 minus 1. Combine your like terms. 3x squared plus 11. So nothing to plug into f of x there because it is literally f of x. So I take the f of x that's given and just pull it into what I have. On, 12 minus 1.
Oh, I thought you only do it for x's. I thought you only.
And the second one, now it says f of 1/2 x. So I'm taking that 1/2 x and I'm plugging it into the x that's in my original function. So I'm going to do 1/2 x squared plus 4 because that is taking 1/2 x and plugging it into the function. But I can't forget the plus 3 at the end. So we're doing f of 1/2 x. Ignore everything else on this slide. And if we go back to evaluating a function, if I said f of x equals x squared plus 4, and I said find f of 1/2 x, you would know I take this and I plug it in there, right? All we did now is take that and add 3 to it. Because this says take that and add 3 to it.
Why is 4 not in parentheses?
Because this went into the x.
Oh, because look, 1/2 is inside there and 3 is outside there.
Correct.
So you do 3 times everything because outside.
If there's nothing inside the parentheses, you're leaving your f of x alone and then multiplying by 3 and then
There's a
subtracting
1
1.
on that x.
This time there's something inside the parentheses, so I plug it in.
That one doesn't go to this one.
That was outside, that was inside.
All right, so then 1/2 x squared becomes 1/4 x squared plus 7. Yeah. Questions?